Trigonometric functions. So in trigonometric functions, what are trigonometric equations? An equation involving one or more trigonometric ratios of unknown angles is known as a trigonometric equation. So in this chapter, we'll deal with all the trigonometric equations, and a value of an unknown value which satisfies a given trigonometric equation is called a solution of that equation. A solution of a trigonometric equation in x such that 0 till 2 pi is called its principal solution. So what are the points of an equation that consists trigonometric ratios? Secondly, the value of the unknown angle needs to be found out. Which satisfies a given trigonometric equation. And third, the solution of the trigonometric equation in x, the solution in x till 2 pi is called its principal solution. Okay, so what's a general solution? General solution of trigonometric functions. Since trigonometric functions are periodic, a solution generalized in a view of periodicity is called its general solution. So each and every trigonometric function has its general solution. So we'll now see each equation and its general solution. So we'll make a table. First is the trigonometric equation, and the second being the general solution of that particular trigonometric equation. So sine theta is equal to 0. So this is the equation. So what is general solution? Theta is equal to n pi. So theta can take the value of n pi, where n can be 1, 2, 3, 4, whatever. So this theta is equal to n pi satisfies this equation, hence it is known as the general solution of the particular equation. The second is cos theta is equal to 0. So theta value ranges between 2n minus 1 pi by 2, where n can be any value. So this is basically the general solution of cos theta is equal to 0. Tan theta is equal to 0. The theta value is n pi. Okay. Trigonometric functions also find its application in solving the sums related to triangles. Suppose we consider a triangle, a right angle triangle here, where A, B, C are its vertices and the length of sides are A, B and C, and this is the right angle. So what does the sine rule say? The first rule is the sine rule, and the sine rule says that in any triangle, the lengths of the sides of a triangle are proportional to the sines of the angles opposite to them. So in triangle ABC, the ratio, the length of the side of the triangle is proportional to the sine opposite to it. So A by sine of A is equal to B. B is the length of the triangle and the angle opposite to it is B. So sine of B, they are in proportion, is equal to C upon sine of C. So this is basically the sine rule, where it says that the lengths of the sides of triangle are proportional to the sines of the opposite angles. So this by this is equal to this by this is equal to this by sine of this. The second rule is the cosine rule. Okay, so in triangle ABC, cos A is equal to B square plus C square minus A square upon 2BC, and these are basically the sides of the triangle. So cos A is basically the angle and the small letters are basically the sides of the angles. Okay, the third one being the projection rule. Okay, so in triangle ABC, A is equal to B cos C plus C cos B. So this is basically the projection rule. If you have to find out the length of the side A, so this is the formula for it, and we can similarly find out for B, and similarly we can find out for C. Now the fourth one being the tangent rule or Napier's analogy. Okay, so in triangle ABC, tan B minus C upon 2 is equal to B minus C upon B plus C into cot A by 2, and similarly we can find for AC and AB. So tan B minus C upon 2 is B minus C upon B plus C cot A by 2. The fifth one being the half angle semi-perimeter formula. So if triangle ABC, if A plus B plus C is equal to 2S, okay, then the half angle formula, that is sine A by 2 is equal to root of S minus B into S minus C upon BC. And we can similarly find out the half angles for sine B by 2, sine C by 2 also. Cos of the half angle, that is cos of A by 2 is equal to S minus A upon BC, and we can similarly find out for B and C as well. Tan A by 2 is equal to S minus A into S minus C upon S minus A, and similarly we can find out for B and C as well. So how now we'll see how to find out the area of a triangle. So area is equal to half BC sine A is equal to half CA sine B is equal to half AB sine C. So this is the formula for finding out the area of the triangle in terms of the trigonometric functions. Now we'll see the self-adjusting property of the trigonometric inverse trigonometric functions, that is function of f inverse x is equal to x. So first is sine of sine inverse x is equal to x, cos of cos inverse x is equal to x, sine of sine inverse x is equal to x if the range of x is minus 1 till 1, cos is minus 1 till 1. Third is tan of tan inverse x is equal to x if x belongs to rational numbers. Fourth, cot of cot inverse x is equal to x if x is a rational number. Fifth, cosec of cosec inverse x is equal to x if x is less than or equal to 1 and x is greater than equal to 1. Sixth is sec of sec inverse x is equal to x if x is less than equal to 1 and x is greater than equal to 1. So now we'll see the self-adjusting property 2, that is in the format f inverse f theta is equal to theta. So now we see the self-adjusting property 2, which is in this format, that is sine inverse sine theta is equal to theta if the theta ranges from minus pi by 2 till pi by 2. Second, cos inverse cos theta is equal to theta if theta ranges from 0 to pi. The third is tan inverse tan theta is equal to theta if theta ranges from minus pi by 2 till pi by 2. The fourth is cot inverse cot theta is equal to theta if the theta ranges from 0 till pi. The fifth one, cosec inverse cosec theta is equal to theta if theta ranges from minus pi by 2 till pi by 2, where theta is not equal to 0. The last one is sec inverse sec theta is equal to theta if the theta ranges from 0 till pi and theta is not equal to pi by 2. So these both are the self-adjusting properties in two different formats. Inverse trigonometric functions. So what are inverse trigonometric functions? If a function f where a arrow b is both 1 to 1 and onto, so this is a function given to us, so its inverse, the inverse of the given function would be f inverse b tends to a. So if this is a function, then its inverse would be f inverse b arrow a is defined as, so if y is equal to f of x is a function given to us, then x is equal to f inverse y. So this is basically a inverse function. This is the first point. The second point is an inverse trigonometric function essentially represents the measure of an angle. So inverse trigonometric function represents the measure of an angle. Third, the least numerical value among all the values of angle y whose sine is x is called the principal value of y is equal to sine inverse x. So now we'll see the function, its domain and its range, that is the principal values of it. So we'll make first a table where this is the function, this is the domain, and this is the range of the particular function, range or the principal values. So first is y is equal to sine inverse x. Okay, so its domain is x lies between -1 and 1, and the principal values of theta is minus pi by 2 till pi by 2. So this inverse function is basically the measure of an angle, that is it is an angle and it ranges from minus pi by 2 to pi by 2, and the values of x ranges from -1 to 1. The second function is y is equal to cos inverse x, that is the values of x lies in the range -1 to 1 and the range is from 0 to pi. The third function is y is equal to tan inverse x, and x belongs to any, it can be any rational number, and the principal values are from minus pi by 2 to pi by 2. Now we'll see cot inverse x. The domain is, it belongs to all the rational numbers, and its principal and its range is till 0 till pi. Now cosec inverse x, x can be less than equal to -1 and x can be greater than equal to 1. So this is basically the domain of cosec inverse x, and its range is minus pi by 2 less than equal to y greater than equal to pi by 2, that is minus pi by 2 to pi by 2, its range where y is not equal to 0. The last is sec inverse x. Its range is same as the cosec, that is x should be less than equal to minus 1 and x should be greater than equal to 1, and its range is from 0 till pi, that is 0 less than equal to y greater than pi, that is y, and y should not be equal to pi by 2. Y should not be equal to pi by 2. So these are basically all the functions and their domains and their respective ranges, that's their principal values from where the theta lies. Now we'll see the reciprocal functions. In the inverse trigonometric, the first one being cosec inverse x. So cosec inverse x can be written as sine inverse 1 by x. So cosec inverse x is the same as sine inverse 1 by x if x is less than equal to minus 1 and x is greater than equal to 1. The second thing is sec inverse x is nothing but equal to cos inverse 1 by x if the same condition x is less than equal to minus 1 and x is greater than equal to 1. The third is cot inverse x is equal to tan inverse 1 by x if x is greater than 0, and pi plus tan inverse 1 by x if x is less than 0. So these are the three reciprocal functions, that is cosec inverse x is equal to sine inverse of 1 by x. That's the reciprocal of it, and their ranges are given. Now we'll see the identities that we follow in a inverse trigonometric function. So now we'll see the three basic identities that will help to solve us various problem. That is, the first one is sine inverse x plus cos inverse x is equal to pi by 2. This is the first identity where if x ranges from minus 1 to 1. So x ranges from minus 1 to 1. Second is tan inverse x plus cot inverse x is equal to pi by 2 if x belongs to all rational numbers. The third and the last identity is sec inverse x plus cosec inverse x is equal to pi by 2 if x is less than equal to 1 and x is greater than equal to 1. So these three are the identities that will help us solving problems.